Let's get started. First of all, welcome everyone. We're really excited to talk about how we use machine learning to power our marketplace. And in the next slide, we'll kind of talk about just an overview for how machine learning and engineering work together at DoorDash, right? So I myself am part of the data science machine learning team. And like all data science machine learning teams, we partner with our eng partners horizontally across all verticals at DoorDash to really kind of introduce and then kind of scale up these ML powered capabilities across all lines of the business. And our goal here is really to optimize for marketplace outcomes across consumers, dashers, merchants, and the platform itself. So in the next slide, I'll give an example about how my own team kind of works on this front. So one of the teams that I lead is the supply and demand balancing team, right? So our team's goal is really to make sure that we're giving dashers the incentives with the best delivery opportunities and earning potentials to come onto the platform itself. So specifically, we use a combination of kind of forecasting, cost curve estimation and optimization programs to really say, okay, right now we're going to give you kind of extra pay in order to kind of make sure you're earning well, you're well utilized, because that we know dashers that are well utilized and earn well are most likely to retain, right? And we want to retain the most high quality dashers and ensure the best outcomes for them. By the way, I'm hiring, so if you're interested, please reach out. But that's just one example of how actually we use machine learning in the DoorDash ecosystem. So in the next slide, we'll kind of talk about very high level about the focus today, right? So we'll talk about how marketplace uses machine learning and engineering kind of infrastructure to really build up these capabilities. So some of the new initiatives that we're working on are kind of fall under these three pillars, right? So one is consumer experience, and number two is the merchant experience, and number three are these kind of new growth opportunities, the new verticals, new lines of businesses that DoorDash is trying to expand into. So we'll go over two aspects of this. So on the engineering side, we're talking about how we're building these new experiences up and scaling them. And on the ML side, we'll talk about how we actually build these models to optimize for these business outcomes. So the next slide will kind of we have the agenda today. So again, welcome again. I'm your host and MC for your questions at the end. And then I think with a keynote speech by Nishan, our fearless DSML leader, and then we'll have a round of lightning talks across different aspects of the marketplace itself. So our chat is disabled. We have a dedicated Q&A channel. Please post your questions there, but also we post updates in the chat itself. So please remember to check that. And then at the end, I'll kind of moderate the Q&A. And without further ado, I'll pass it off to Nishan. Oh, wait. Most important thing. So we are hiring for a range of roles across kind of teams and seniority levels. In particular, we're really looking for candidates with experiences in the 2+-sided marketplace. DoorDash is a really complex ecosystem, and we need a lot of different skills, right? So some of these skills are pricing optimization, graph learning, search and recommendation systems, in particular with deep learning and reinforcement learning, and then also causal inference to really help us understand the impact that we have on our ecosystem. Okay, so if you're interested, please reach out on LinkedIn, or here's a handy kind of code that you can scan, or visit our careers link. Okay, so now truly, without further ado, I'll hand it off to Nishan to give an overview and of the marketplace.
Thank you so much, Gisselle, for that wonderful introduction. And thanks, everybody, for joining us today. My name is Nishan Subedi. I want to talk to you about some of the challenges we face in optimizing for DoorDash's marketplace platform. Before we get into that, a little bit about me. I just recently moved to the East Bay. I used to live in Salt Lake City before. This picture is me with my lovely wife and parents somewhere in the waterfalls in Salt Lake City. Had a blast living there. I've been at DoorDash since July of 2022, very recent. I wanted to witness the growth and excitement of what we're building here firsthand, so couldn't resist the opportunity. I lead marketplace machine learning. This includes the customer experience, merchant experience, growth, and ads. So lots of complex problems, exciting problems. You'll find me hiking or biking or skiing or playing tennis in my free time. So with that, let's kind of dive into the problem space. So we've built an amazing platform so far, but we're just getting started, and we want to build a lot more. So what does building the next generation marketplace platform at DoorDash's scale look like? I want to give you an overview of that today. So far we've built the best selection of restaurants, and we've been able to personalize our home and store feeds through multiple iterations. But where we want to go next, our next generation platform, we want it to be affordable for all customers with exciting promotions for them. We want the best selection of all local merchants across multiple verticals. We want to introduce you to new merchants that you love across these verticals you may not be aware of. We want to provide the best subscription service for our power users as well. So to build this experience, in the next slide, I'll talk about the 3 primary challenges that we want to tackle to optimize for our marketplace platform. The first of them being offering up an exciting selection for our customers. In the next slide, you'll see why this is a hard problem, right? So essentially, how can we find the best merchants in the world that people get excited about and offer them up in our platform? Currently, we use a variety of signals to capture the best restaurants in the area, but this is not enough with our growth and kind of adoption plans. We want to be able to leverage customer intent to determine where we have selection gaps on a per customer level. So we want to make sure every customer is getting a delightful selection that they can pick and choose from. And we want to be able to incorporate affordability into the selection itself. We also want to rapidly expand to new verticals such as grocery and flour in the coming year. So we also want to be able to solve this challenge at the DoorDash scale while offering competitive prices. So in the next slide, we'll talk about menu inflation and why this is such an important challenge to solve. So one reason we are not able to offer competitive prices, as you'll see in the next slide, is menu inflation, which we roughly define as a relative markup on menu item prices on DoorDash compared to in-store. This leads to a bad customer experience. It damages the customer's trust in the platform. It leads to volume loss for merchants. And so as you can see, it's a loss-loss situation for everybody involved, for DoorDash, for the merchants, and the customers. But this is a hard problem to solve, right? How do we know prices for all our merchants' catalog across the different platforms and their store at all times? Currently, we have algorithms that detect inflation patterns, and we use manual verification process for the merchants we've identified, as well as for our top merchants. But this is not very scalable. We want to be able to determine menu prices from in-store and web menus on a regular basis and feed this into our multiple algorithms as well as actions we take with merchants to make sure the customers are always getting the most affordable options at DoorDash. So in the next slide, another way we can handle affordability is to determine the best promo offerings for our merchants. This is also a hard problem because how can we smartly pick, in the previous slide, I think we talked about this, how can we smartly pick promotions across endless combinations for each merchant? Right? Currently, we run a number of simulations to determine the best promotions and the best outcomes based on these promotions. But where we want to go to next is be able to personalize these promotions that power DoorDash merchants' growth and are tailored to each customer's unique needs. So, we want these promotions to be a growth lever and a lever to achieve business goals for our merchants while meeting our customers' unique needs. So that kind of is a brief introduction to the first challenge, as you'll see in the next slide. The next challenge, the next part of this challenge is to personalize it for our customers. how do we personalize these exciting offers and selections for our customers? Because not everybody is excited about the same things. So in the next slide, you'll see that we've done a lot of work to make our store and home feed smarter. So we've used ML to drive a number of key experiences for our customers, such as featured items on the stores, attractive discounted offerings, as well as kind of recommendations for what we think you'll like, or something that's complementary or substitutable for items you are looking at currently. And there's a lot of personalization involved here, and we can do a lot better job as we iterate on these as well. So in the next slide, this brings us to our next challenge. Our second challenge we want to address is our ability to understand our catalog and tie it to the customer intent. So this is really at the heart of what we need to accomplish as a marketplace. DoorDash has grown rapidly in the past years because of the selection we offer. But understanding our catalog is hard, as you'll see in the next slide. Why is this hard? Because no standard taxonomy exists for restaurants, so we've had to build our own. We need to support multiple verticals as we quickly ramp up across the local merchants that we offer. And this brings about a challenge of scale. How do you onboard rapidly all these new merchants where, you know, we haven't had time to build our catalog as thoroughly as for our mature markets? And also is servicing multiple verticals brings about unique ambiguity challenges, such as when you search for pasta, are you looking to order a pasta dish right now, or are you looking to cook some pasta at home? You've got your water boiling and you just realize you ran out of raw pasta and you want somebody to deliver it to you quickly. Also, catalog understanding is fundamental to the data-driven decision-making process. So as I talked about earlier, in identifying and solving for our selection gaps, our catalog becomes a critical element of knowing where, what kinds of gaps exist. So in the next slide, you'll see in building our restaurant taxonomy from the ground up, we've had to create hierarchies of things such as dishes and beverages, cuisine types, dietary preferences for our customers, as well as ingredients involved in cooking these food items. Next slide, we talk about what we're doing now. So we effectively are leveraging a lot of human annotation and using that to generate ML-driven tags. So we've achieved a level of scale here because at some point we no longer need additional human tags, and our machine learning models are smart enough to classify and tag our items moving forward. But this is not where we want to stop, right? In the next slide, so what we're doing next to understand our catalog is we're building a unique universal product catalog across our merchants. So as we expand to new verticals, we're finding that a lot of brands have the same offering across different merchants, but the way they're describing these elements differs slightly. However, they refer to the same element. So we want to be able to identify these universally across our catalog. We also want to be able to integrate customer intent to get a better understanding of what our catalog looks like. And we want to be able to translate knowledge across verticals. So in the next slide, we talk about the third challenge that we want to work on, which is now taking all this to improve the customer experience. And this poses a lot of challenges onto itself. So in the next slide, we'll talk about challenges in building an everyday affordable customer experience for our customers. This is hard because we have to make sure each and every one of our millions of customers finds exactly what they're looking for, with a consistent experience without degrading the quality of the delivery itself. Currently, we personalize our major app experiences, as well as we pin a number of affordability-centric carousels so that customers can easily find items at affordable prices. But where we want to go next is we want to be able to understand our customer intent based on the interactions they have across our platform and be able to personalize consistently across all touch points. So this may be from the marketing channels that they are first introduced to DoorDash to the promotions and offers and notifications we send them, all the way through the experience and their checkout. We want to provide this holistic, personalized experience for them while supporting a large set of unique needs our customers come to us for. And we want to be able to highlight and create affordable options for our customer while doing so. The next slide, we'll see that this is challenging not only from just a personalization perspective, but one unique problem we run into is these marketplace network effects. These create coupling across our multiple optimization objectives, so making every problem just a little bit harder. So as an example, if we highlight a quality merchant to, let's say, a majority of our customers with attractive promotions, they get very excited about this merchant. And so this merchant gets a lot of volume. And with this high demand, there may end up being lines on the merchant of dashers trying to deliver these items quickly as possible to our users, which may end up degrading the customer experience. So, our personalization is important not only to provide the customer what they're looking for, but also to ensure that they're getting the best final product from our platform. So, with that, just wanted to make a call out for in the next slide to join us in helping us build this next generation platform at DoorDash's scale, where we tackle affordability, continue providing the best selection across multiple verticals, provide really attractive promotions and subscription service for our power users. And we hope you'll join us in building this experience with us. Next up, we have a really exciting panel of lightning talks, and I want to hand it over to Yuza to talk about homepage recommendations. Thank you.
Hey, thanks. Thanks, Nishan, for the introduction. Hi, everyone. My name is Zhang, and I'm a machine learning engineer from the Discover Personalization team. So I want to talk about building homepage recommendations with exploitation and exploration. So first, a quick introduction of our agenda today. So first, this presentation will focus on the two key challenges and our solutions for that. So first of all, it's relevance ranking for mixed types of homepage entities. We're going to go into details soon. And also, our solution for this one is to developing a deep learning-based learn-to-rank model, which we're going to refer to as universal ranker, which is UR later on. So the second challenge would be finding the optimal balance between this exploitation and exploration process to optimize our consumers' experience. And to solve that, we developed a ranking framework integrating both this universal ranker and offer confidence-bound algorithm. In the next place. So for a quick introduction, it's like, what is exploration and exploitation? So personalized recommendation are a combination of both these cases. So the first case is what we already know about our consumers, what they like. This is being known as exploitation, and we want to memorize and customize their experience. The second part is we want our consumers to explore new things and enrich our understanding of their experience such that we can further optimize for that. This being known as exploration. Next, so first of all, for the exploitation part, we have this challenge for ranking different entities. Allow me to just quickly introduce our entities on the homepage. As you can see from the left-hand side, we get this carousels and store feed. In this carousel, we have item carousels as well as store carousels. These carousels, you can engage with them by scrolling horizontally on our homepage. And also we have this store feed, which is at the bottom of these carousels, which you can scroll vertically to explore new stuff. Even within these carousels, you can see we have items and individual stores in these carousels. So to sum up, so basically we have these entities at different levels. For single entities, we have stores and items. And also we have nested entities, which is store carousels or collections and item carousels. So anything that can be placed into a single slot, we will just refer it as an entity on the homepage. So our challenge here is that we need to be able to compare apples and oranges. Why is that? Because first of all, we have these scalability issues. Basically, we cannot build a single dedicated model for each of these entity types. That is not scalable. And also, even if we do that, it's hard for us to calibrate model because we need to compare them consistently with their relevance. And we cannot do that with dedicated models as well. So in the next part, we're going to introduce our solutions to this. So our solution is to build a universal ranker. If you look at the figure here, so we have this two comparison experience, one we refer as legacy, another as new. So the legacy ones, we just, for example, we have all the carousels at the top and we follow with these stores. This kind of different colors denotes the relevance levels of these different entities. So from this legacy one to a new optimized solution, we will say, it doesn't matter which entity type it is. We just simply want to optimize the most relevant, the most high quality entities to our consumers, enabling an intermixing experience. So what the model we're building is based on a wide and deep model initially developed by Google, and also combining some certain concept from the deep learning recommendation model initially developed by Facebook or currently Meta. What it does, it jointly ranks vertical positions for mixed type of entities by the order of their peak probability of conversion, which we define currently as our relevance scores. So from high to low, we define 3 hierarchical level of entities, which we are very similar to the ones we represented before. So we have this store carousels, and then next level is individual stores or item carousels. And the lowest level is the individual item. Think about this, when the model look at these different entities, it would, when you look at the higher level entities, it will be, from model point of view, it basically is a nested order list of the lower level entities. So one store carousel could be viewed as a nested order list of different stores. That's how we make all of these different entities consistent to the model. And the features we'll be using for this model is from 4 major sources. One is entity related features, which is, for example, the store's quality, the store's ratings, the items cuisines, and also some quality metrics. And also next is the consumer related features. For example, the consumer's affordability, the consumer's taste, the consumer's experience with our platform, and then also consumer entity engagement features. This is the overall sparse features. For example, we're gonna have the consumer store, consumer item pairwise engagement history, such as views and clicks and orders. And the final ones are the context related features. For example, the ETAs of the stores, the delivery fee of the stores, and weather conditions and all other contextual information. In the next part, we're going to go into the challenge for why we need exploration on top of our exploitation. So we could end up with unfavorable consumer experience when only focusing on exploitation. Several examples would be recommendations for new consumer might be biased towards their initial engagement. And this exploitation only process also delay our response to consumers' preference change over time. And also consumer could also be bored with what we're being perceived as a stale homepage because this might be flooded with all the stuff they already engaged with. And overexploitation could also cause fairness issues over time as popular merchants become even more dominant, where new merchants recede into our platform with background, having fewer opportunities to be shown to our consumers. So all of this could be referred as the filter bubble or ideology problem. Basically, consumers begin to perceive only a small subset of merchants with whom they're already familiar with, creating a self-fulfilling prophecy. So we're gonna just go into the solutions here. So what we do is we combine this upper confidence bound concept into our current model system. So we just quickly go over our ranking framework. So for any consumer at a given location and time of the day, so we're gonna have 3 stages of our ranking framework. First one is the first pass ranking. This is the information retrieval stage. We just get all the candidates available to our consumers, such as stores and items. And the second pass ranking filters the pre-ranking candidates and horizontally rank them within nested entities. For example, we're going to pre-rank the order of stores in a carousel such that it can be further horizontally ranked at the final ranking stage, which is mixed ranking all the different entities vertically on our homepage. This simple equation here is for illustration purpose. So we have this score from universal ranker as a mean estimator, and we have another term we call uncertainty term to represent this upper to give uncertainty to quantify the uncertainty for the upper confidence bound. So what this thing really does is that it keeps the most relevant entities at the top when you have very high UR score for the first term. And the second part is that it will downrank entities that has sort of relevant, which has a median UR scores, but has very high impressions, which will give very low uncertainty scores from the second term, brings down the overall score. And third one is that it will surfacing new entities, even with low relevant scores, but they may having very high uncertainties, such that we can still have a combined relatively high score to surface them to our high positions to be shown to our consumers. So in the next, so we'll talk about some of the results here. So through online experiment testing, so we found that our new experience drives consumers to engage more with our recommendations and converts on the homepage. And more consumers are interested in trying new merchants and items they never ordered before. We see a static lift in the restaurant new trials from our consumers. Also, we opens up more opportunities for local or new merchants because we do see a lot of local and new restaurants being surfaced and getting new orders. And we also achieved GMV lift to our internal marketplace as our consumers actually orders a bit more from new stores rather than their previous engaged store. So finally, we want to talk about our future works. So we have only introduced exploration to vertical ranking so far, and we are working in progress to testing this for horizontal ranking within store and item carousels to even optimize the consumer experience. Second, testing similar ranking algorithm at the second pass ranking stage, meaning we're going to go one step further to our ranking at our ranking funnel. The third one is personalized exploitation and exploration trade-off for different consumers based on their shopping behavior and exploration sensitivity, because we know consumers kind of like having different experience and response to our exploration. Finally, we would also try Thompson sampling as alternative approach to our current UCB approach. So with that, I would be handing over to our next speaker, Ujjwal. So he will be talking about taming content, discover scaling challenges with Hexagons and Elasticsearch. Thanks.
Hey, you. Thanks for the introduction. Hey, everyone. I'm Ujjwal, and I'm a software engineer at DoorDash. I primarily work on the consumer discovery experience, and I'm going to be talking about content on the app and what challenges we face in showing that content. So, as you can see, I'm going to talk about a few things. I'm going to start with some introductions about what are the different kinds of content that I'm going to talk about, like banners and carousels. What are the problems that we face while retrieving them and showing them to the users, how we attempted to solve that problem, and what was the impact of that, and some conclusion in future work. So as you can see in the next slide, I have some screenshots of the DoorDash app. As soon as you open it, as you can see in the first, you see different kinds of content everywhere. The first one that I've highlighted is a banner. A banner is something that can be used to showcase a promotion. It can be used to showcase any kind of other information about some event. It can be used for various purposes. So that is available on various surfaces on the consumer app, such as the home page. In the next screenshot, you can see it's on the store page, and it's on many other pages. And the other thing that I want to talk about is carousels. So what are carousels? They are basically grouping of either stores or grouping of items that belong to a certain category. So for example, you can see most loved, and there are some stores which belong to this category. And you can scroll them horizontally on whatever surface you are. And when you want to see more of the stores that belong to this category for you, you can click on a gray arrow and it takes you to the Carousel See All page, where you see more of these stores that belong to this category. So that was an introduction to the different types of content that we show at DoorDash. So how are these created, right? So these content can be created either programmatically, that is through some rule-based or machine learning algorithms, or they can be curated manually through strategy and business operators. So we have a system called the campaign system, through which you can create these banners, these carousels on any surface. And it's very, very flexible and powerful. You can do things like who to show. We have consumer targeting, A/B testing, and so on. When to show, you can decide, okay, this should show from 10th January to 12th January 2022. And you can also mention day parts, that it should be Monday, Wednesday, Friday, 7 a.m. to 7 p.m. and so on. You can decide where to show within the app, homepage, store page, and you can also decide what to show inside. Should I show stores? Should I show items? Should I target businesses and so on? And also what kind of format I want to show it in, right? So it's very, very flexible model that we give to our internal ops to be able to create these kind of content. So as you can see, like in the next slide, I want to talk about why this can be a boon and a bane, why this flexibility can also cause a problem. So briefly looking at the architecture, how we render content is like you open your app, you go to the website, it hits one of our services. And the first thing we do is, since there could be multiple stores in your radius, there could be like thousands and thousands of restaurants, grocery stores, pet supplies, pharmacy, and so on. We use machine learning algorithms to determine what are the top, few stores that are relevant to you. We fetch them. And once we fetch them, we make a call to our campaign service and we try to fetch all the campaigns that are related to each store. So for example, even after doing a relevance, we say we have 1,000 stores. We want to fetch campaigns for each store. So imagine one request has 1,000 stores and each store has like 100 campaigns. That's a huge fan out problem that can happen. And this all happens online. And this fan out factor just is contributed by 4 major factors. One is traffic, organic traffic to the app as a whole, the number of verticals. Now, verticals are things like restaurant, grocery, convenience, pet supplies, etc. Number of stores in each vertical, and the number of campaigns for each one. So as you can see, it causes like a major fan out problem, and we don't want the app to be slow and buggy. So with time, these 4 factors contributed to more and more fan out. So how did we attempt to solve the problem? So there are some obvious ways that you can start. The first one is we started doing some batching. It helped reduce our overall latency, but it increased overall cost because there are so many services involved. Now you're making more network calls. There's more impact on multiple microservices, databases, and caches, and so on. The other thing then we thought is, can we be a little more smart? Instead of fetching for 1,000 stores, can we group them by some geo location and fetch the best amongst them, right? So that's the next thing that we did. And we evaluated various libraries and we chose H3 as the library that we would use to retrieve. And apart from that, earlier we were fetching all the data and filtering in memory, and we moved that to filtering at the storage layer. And we found Elasticsearch to be the best for that, to retrieve a smaller set of relevant candidates. So if you see in the next slide, it shows how the fan out problem reduced. Instead of making like multiple calls, now 1,000 stores could be represented by say 100 geohashes. So and for each of those, you can fetch the best campaign. So the fan out reduced drastically with this approach. And we had massive impact of this. For example, if you can see in the next slides, doing this kind of approach, we were able to reduce our costs big time. Our Cassandra database cluster size reduced by 45%, Kubernetes pods reduced by 75%, Redis cluster, and overall, it had no impact on business metrics. It was neutral in the sense we were still showing everything that we were showing before, maintained all the SLOs, and had huge cost savings. So the conclusion that I would like to make is solving fan out problems for content discovery is a hard problem given business constraints. Best way is to go iteratively and try to solve it and see whatever tools we have available. And some of the approaches we are thinking of for the future is like, instead of just using one level of geohashes, we can do hierarchical based on dense locations, sparse locations. We can do a offline plus online kind of system. We can use some first pass ranker to reduce the candidate set even more, and so on. So yeah, that's mostly about it. And now I will hand it off to Robert, who's going to talk about fuzzy matching to improve precision and recall. Thank you.
Thanks for the introduction, Ujjwal. Hello, everyone from DoorDash headquarters in San Francisco. Ironically, I'm sitting about a few yards from this artwork that everyone, including me, is using as their background on Zoom. Anyway, my name is Robert Kaspar. I've been a data scientist here at DoorDash for a few years, and I'm going to talk about high-performance classifiers that are based on fuzzy matching. So here's an outline for today. First, I want to introduce an application for this work, which is grocery ads on DoorDash. Then I'm going to zoom in on a particular problem that powers those ads. This is a product matching problem, and go on to discuss some simplistic attempts to solve it that aren't good enough. Finally, I'll present our final solution, which is to use fuzzy matching with human in the loop, as well as some kind of tricky algorithm improvements on top of that. So first, let's talk about the application. I have a screenshot here that's sort of a typical convenience and grocery ad that we might run on DoorDash. So once you're already on a convenience page, like let's say Walgreens, then you can search within the store. This is one example of an ad surface for say iced tea. And in the results, you might see some that have an ad banner that are promoted by advertisers. So there are 4 parties that are involved in this process. First, there's the consumer, so you, and there's DoorDash. And then the last 2 are the grocery store, whose only role here really is to host the ad. So that's Walgreens in this example. And then the brand owner that buys the ad. So this is Gold Peak, the brand in this example. So the problem that I'm going to talk about today is that these last 2 bullets, the grocery store and the brand owner, don't always refer to products in the store the same way. And this causes some sort of counterintuitive problems. I'm going to motivate that more in the rest of the presentation, but first I want to zoom out and give you the context of how this fits into serving ads overall. So let's look at this figure in the lower right, starting at the bottom where there's an actual ad impression. That's where the ad is shown. There are several things that feed into this. So the step right before that is there's an auction held in real time where all the advertisers who are interested in showing you an ad compete to see who's going to win the auction and actually get to serve it. There are 2 main inputs to that. One is the user input. So what did the consumer just do? For example, you might have just searched for iced tea on Walgreens. That's the input that drives what kind of ad you can see. And then on the other side, we have to check whether advertisers who sell iced tea products are interested in running an ad campaign to check whether they're actually wanting to enter the auction. And it's this part that I'm going to focus on in the presentation today, because there are really 2 pieces. The advertiser might have a list of products that they want to advertise. And then on the other side, DoorDash has all of these different merchants with their own catalogs. And these are sometimes using different terminology, and it's hard to draw the connections between them. So I'm going to motivate that more on the next slide. Here's a fictitious example of what this product matching problem looks like. On the left, you can see an advertiser's product. I made up fizzy cola. And on the right, you might see a bunch of, really this should be an infinite list of all of the items that are on DoorDash. Any one of these could be a match to that specific product that the advertiser wants to show. And so I gave you one example of a true match here. It's in green. So it's fizzy cola can, 12 ounces. The name is like slightly reworded from the advertiser's description of it, but it's obviously the same thing. And then I'm showing a bunch of false possible matches as well. And so we need an algorithm that can identify all of these true connections without accidentally finding the false ones. So my favorite part of this work is that the business interpretations of the mistakes that this algorithm can make are really clear. So let's think about those in terms of false negatives and false positives. A false negative would be where there exists a real match, but the algorithm fails to find it because it isn't sensitive enough. So the interpretation there is that we can't show as many ads. We're not catching all the opportunities where we could have shown an ad because we didn't understand the identity matches between the products on the advertiser side and on our platform. So you could say that like there's a revenue impact there that's roughly linear, probably a little bit less than linear actually, in the number of false negatives that this matching algorithm makes. But the false positives are more interesting. So some kinds of false positives we don't really care about. So let's look at the top red box in this figure that I showed you. Fizzy Cola 20-ounce bottle. That's pretty close to Fizzy Cola 12-ounce can. And if we accidentally thought that those 2 things were the same and showed an ad based on that false information, no one would really complain. The consumer experience would still be good. The advertiser would be showing a product that's very similar to the one that they wanted to show. They might be a little bit annoyed because perhaps they're pushing their cans right now and they don't care as much about bottles. But this is a minor mistake and it doesn't have very strong consequences. Similarly, if we show the wrong flavor of product or something else like that. But the worst kind of mistake that we can make is if we accidentally mismatch brand when doing this catalog mapping. So for example, if you look at the third box here, competitor Cola is another fictitious company that I made up. If we accidentally misidentify a connection across different brands, then what will happen is we serve an ad that's paid for by the wrong brand and promotes the wrong product. So this would be a disaster, and we'd have to kind of shut it all down if that happened. So we really need to make this mistake 0% of the time. So that's the problem. And on the next slide, I'm going to talk about simple ways that you could solve this problem. The most obvious solution is to use barcodes, universal product codes. So if you look carefully at any consumer packaged goods product, you'll see this little barcode on it. And this supposedly uniquely identifies the product. It's not quite unique, but that's a different story. Anyway, the problem here is that often these codes are missing, and sometimes they're even incorrect. And so, of course, we want to use this information to solve this problem, but it only gets us about halfway to where we want it to be. You could think of it as a high precision but low recall classifier for this matching problem. And instead, what we turn to for the work I'm going to talk about today is fuzzy matching, which is sort of the opposite. By nature, it's a higher recall but lower precision approach. So the basic idea here is to look for near matches in string terms between the item name as defined by the advertiser and as defined by the merchant on DoorDash. So the more words or even characters within words that overlap, the better. So if you use a fuzzy matching algorithm, it will score each match candidate and just assign that from 0 to 100 for today's purposes. The way that you convert this to a classifier is you draw a threshold. So we might say any item match that scores above 80 is considered a true match, and anything that doesn't meet that bar, we're just going to discard. So these approaches are not good enough, and I'm going to show you why on the next slide. This plot here on the left shows performance of that last approach that I mentioned. If you just use fuzzy matching out of the box, how well does it perform in terms of precision and recall for this classification problem? And again, that's a function of this threshold that I just mentioned, of the sensitivity bar that you set for the algorithm. And so let's just look at the far left here. If you use a threshold of 80, like I gave the example of, you can see that the recall is around 60%. So you're finding about 60% of the true matches that are out there with this algorithm, but the precision is only about 20%. So you're making a ton of errors. More than half of the time, you're identifying mistakenly a wrong match. And of course, as you increase the threshold, then the algorithm becomes less sensitive. And so you make mistakes less often, but you also find fewer true matches. And with these performances, around 50% for both precision and recall, this just isn't good enough for us to solve the business problem. So we have to take extra steps here. The main thing that we changed is we added human in the loop. So by this, I mean that every match that was generated by our classifier was manually reviewed, which is really a heroic manual effort. And this effectively greatly increased the precision of this low precision fuzzy matching approach. I'm not going to tell you exactly how much it did. I don't want to reveal too much secret sauce, but I'm going to talk about some other improvements that we made too. So we also tweaked this kind of overall system. Once you have the fuzzy matching classifier plus human in the loop review, there are a few other tricks that you can add to get your metrics as high as possible. The main trick here is a pretty simple and intuitive one, which is we didn't just ask many reviewers to look at the best candidate, the best match candidate that the fuzzy matching algorithm produced in each case. We took the several top candidates and checked for a true match in all of those. So this is unusual because it lets you increase both precision and recall at the same time. You're basically finding more true positives without finding more false positives. So this is a huge improvement. And then the other two tricks that are a little bit more subtle are whenever you're doing a matching process, between one population and another, if you can find ways to trim those populations, then you'll decrease the number of false positives that you find. And so two ways that we did that are by limiting the search space based on business impact. So when we were first rolling out this model, we focused on the stores that have the most traffic on DoorDash and the advertisers that we thought would matter the most for our ecosystem. And by excluding other possible matches, we made fewer mistakes. And finally, we don't just know about item name on both sides. We have other metadata too. For example, size and quantity and some other information. And so if you use those to constrain the search space, then you can also limit the number of mistakes that you make. But to make a long story short, in the end, we did manage to achieve 99% precision for that brand mistake that I mentioned was so costly that we need to avoid. It met our tricky business problem standards. With that, we're done with all the lightning talks, so I'm going to hand it back to Gisselle to moderate the Q&A.
Awesome. Thanks, Robert. All right. So we have a bunch of questions. So we're going to be pretty selective here. I'll start off with one on the hiring side. I'm personally not hiring any kind of like, junior roles for like my team specifically. But again, I think Ezra has shared a lot of kind of like really helpful kind of like links and forms for kind of like, the broader kind of like team hiring. I would definitely check that out because I definitely know that like, at the broader team level, we are hiring across all different levels. And with that, I'll pass off to Nishan. You have a question for a more senior role. Are you hiring for like E7 plus roles in DSML, particularly in kind of like search and discovery, marketplace optimizations?
Yes, thank you. We are hiring, and you'll see in our career page, we have a job rec open for this as well. We are always looking for top talent, especially in this area. Particularly around deep learning expertise and the ability to integrate that into discovery to provide a more unified discovery experience. So, if you're interested, you can reach out to me as well. We can talk more.
Awesome. And then another question, how do you build a model or embedding space that allows you to kind of like rank items, for example, dishes and stores in the same space? Is everything trained using a click-through rate objective?
I would love to defer this question to the E7 we hire. But yeah, this is a open and pressing problem for us. We are currently actively exploring multiple different opportunities. Two tower-like models look promising. Multiple objectives have proven a lot of value, and we're keen to apply those approaches as well. But this is an open exploration space for us. Look out for blog posts coming from us shortly on this.
Awesome. And the final question for you, Nishan, do we also run experiments in the marketplace?
Yes, so absolutely. Our culture is very experimentation driven. We run hundreds and hundreds of experiments across all of DoorDash to power our decisioning. I will link to a blog post that talks in more detail about statistics, our experimentation engine. This is also a particularly interesting space because of the networking effects I talked about. So we have some unique challenges that make it fun to work on these.
Yeah, that is awesome. And Ezra, I think you can kind of like share the link with the folks in the call. So moving on to you, I think we have a question from Tarun. Are you doing anything on device models for like mobile platforms?
Sorry, I'm muted. So can you be more specific for like device models? I'm not sure what that's referring to. So I guess in our current model, we do kind of like having this different categories for various different models. For example, you're definitely having a different experience for a desktop experience versus the mobile. And we might having a little bit different consumer behavior from iOS and Android side as well. So we're taking the signals into the model, but like we're not building dedicated models for those, if that's answers the question. Yep.
Cool. And then we have another question from like Shuai, who's curious if this kind of like bandit is like on policy or off policy.
For that, like, so I think it's kind of like on policy.
Got it. So I think moving on, Ujjwal, so I think from Shiraz, how do you determine what's a kind of like a most loved establishment, right? Like does the criteria also depend on the vertical?
Yeah, that's a great question. So we have different kinds of carousels, and each carousel can be configured in whatever logic you want. So specifically for most love, there are like multiple criteria that we use to evaluate things like stores with the highest consumer ratings, stores with the lowest canceled orders, plus in the last 30 days, in the last 60 days, like we try to see a trend. Also stores which have the ratings, not just for this month, for like last year, how many times they had like incorrect orders and things like that. So we judge quality, and then based on that, we determine specifically for this carousel.
Awesome. And then not really sure which slide this is referencing, but it looks like there's, 4 different types of like target audiences, right? So is there any way you kind of like elaborate on that?
Yeah, I think it was about how flexible our targeting is, where we can decide, we can create or config campaigns to decide who to show, when to show, and so on, right? So think of it as like a tool available to you, and you can highly target things like what kind of consumers you want to reach out to, right? What kind of A/B testing experiments you want to run on? How do you want the split to be? What kind of different buckets do you have? You want to show it only from certain time to certain time. You want to show it only, at certain time periods within the day, and what days, right? For certain content, you want it to show only on weekends. Certain things you want to show it only Friday nights. Things like that. And then you can also configure where do you want to show it in the app. So these are the different kind of flexibilities that we offer so that you can target content.
Got it. And then I really love this kind of like last question here. Just like, at a high level, right? Like how important is the effort to kind of like personalize the homepage versus like improving the search? I think, the questioner is not alone in saying that like, a lot of the times when we use DoorDash, we have like this restaurant in mind, right? So we go directly to search. How do we kind of like, think about like, the relative priorities of like, optimizing the homepage versus like the search?
Yeah, I think that's a great question. So it's not a matter of optimizing A or B. We do both. We want to personalize the homepage as much as possible, and we also want to improve the search user experience. So depending on the consumer and the moment they are in, they could either go to search if they have something in mind, or a lot of times the same person might not know what they want right now, and they would love to see what's for example, what are the local favorites. They want to support local restaurants, right? They want to explore which ones are those they don't know. So we definitely have a healthy balance between homepage and search. At current points, I would say that it's more there's more traffic towards the homepage. There's more conversion, like people find what they want on the homepage today, but we continuously will improve the homepage personalization as well as search, because they're two different ways of finding what you want.
Yeah, I love the and instead of the or framework. All right, Nishan, I'm gonna put you back on the spot. So question for you, are menu prices set by the merchants? And how are we kind of like solving the inflation problem without actually hurting like, the platform profitability?
Yeah, that's a great question. So the menu prices are set by merchants. However, we surface merchants based on how attractive they are to customers, and price has a huge factor in determining that. How do we solve for inflation without hurting DoorDash profit? When we've seen that when prices are inflated, nobody wins. Like we don't actually make a profit with inflated prices because customers don't want to buy it. So we operate with thin margins, and we rely on economies of scale to run and sustain our business. So inflation actually we find hurts our business and our merchants' business. So being able to surface attractive products to our customers at affordable prices for them seems to be the winning formula for everybody involved.
Thank you. And I'm going to keep you on the spot. So how do we think about kind of like making DoorDash more competitive than maybe Uber Eats, right? In terms of like, pay for like Dashers.
Considering we have an expert here, maybe I'm going to defer this question back to you, Gisselle.
Well, that is a great question. I think it's really about kind of like offering the best delivery opportunities, right? And to our point, a lot of it is in kind of like, one, base pay, and then also incentives. So I don't want to talk about too much about like the numbers here, but like we have a variety of kind of like incentives or Dashers, right? In particular, kind of like our top Dashers. And that's kind of like, distributed throughout kind of like how we pay our Dashers for like effort in terms of distance and time, but then also kind of like when there's kind of like a supply crunch, how do we kind of like think about like, okay, giving out like challenges or like streaks. So it's really ensuring that kind of like, we have like the best delivery opportunities in terms of earning potentials. And then also making sure that like, we have the right mix of dashers and that are on board at the right time and place. And all that is done through a combination of a machine learning, OR, and then forecasting. So, we're really looking for you guys here. Okay, so Nishan, back to you because you put me on the spot. How many ML teams are there in the marketplace org?
Yeah, great question again. So on the data science machine learning side, we're set up as horizontal, and we're constantly evolving. Roughly, our focus areas are, as I mentioned, customer experience, merchant experience, growth, which includes kind of marketing promotions, notifications, as well as ads. We also work very closely with teams on the engineering side, and we're constantly evolving exactly what organization structures here look like to best suit our business needs. What we're discovering now is that we on the DSML side need to focus on fundamental problems that can apply to multiple different parts of the organization and allow the product engineering teams to make quick, rapid iterations in terms of solutions that we're putting out. So, I think any organization structure in paper won't exactly map out to how things operate. We rely a lot on partnership and collaboration across our engineers, scientists, and everybody else involved. So regardless of kind of what the structure is, you will always be in collaboration, working very closely with your peers across boundaries.
All right, thanks, Nishan. And I think that's all the time we have for today. Again, thank you everyone for coming. And then, a hearty thanks to all the panelists here who gave us kind of like really exciting insights about how Marketplace works.